Happy morning, students. So today we are going to learn about the nuclear physics. So I hope we have been learned about atomic physics. In atomic physics, we have been learning thoroughly about the structures of atom, how atomic structure has been evolved from the past to the present. And we also studied about various atomic spectral series in that. So as the continuation of that lesson, so it's called nuclear physics. So it is going to talk about the nucleus, right? So in this lesson, we are going to learn about what is the nucleus and what is composition. Due to the nucleus, what are the processes has been involved in it, and how the nuclear fission, fusion, nuclear reactor, and various radioactive processes, how it is evolving. So we are going to study that in detail. So let's start the lesson. So it is a basic introduction about the lessons. So we know that atom has been made up of a central part called as what? Nucleus, and it has been surrounded by what? Electrons. So from that only we are going to talk about the composition of the nucleus. So what is the nucleus has been made up of? So nucleus, if I say nucleus is the central part of an atom and its size is what? So size is 10 power minus 15. Right? So 10 power minus 15 meter is the size. If they ask about the size of the atom means we have to tell about 10 power minus 10. So size of the atom they are asking means atom size is what? 10 power minus 10 meter. And if it is the size of the nucleus means it is very small in size, 10 power minus 15 meter. Right? So we know that if I say draw an atom means we can say that the central positive charge and has been surrounded by rings of negatively charged electrons. Right? So by means of Rutherford experiments and everything, we have clearly studied about the atomic structure. Now we are going to study about the nucleus. So nucleus is composed of what? Only two elementary particles. One is called proton, another one is called neutron. So proton is what? Electrically neutral in nature and it doesn't have any charge. But proton is a positively charged particle. So it has a charge of what? Plus E. Right? So the charge is not equal to that of an electron, but it is the opposite in nature. So we say the charge of electron means what? Minus E. We take the value of 1.6 into 10 power minus 19 coulomb. Here we can say that it is plus 1.6 into 10 power minus 19 coulomb. Because the charge has been expressed in terms of unit called what? Coulomb. Is it clear to you? So if they are asking about what is the component or composition of an atom means we have to write these three. So what are they? Neutron, proton and electron. Suppose if they ask the composition of nucleus means we have to write about what? The neutron and proton. So what is the charge of neutron? It is electrically neutral. That means what? So nothing is there. So no positive or negative. It is neutral in nature. So we say that the charge of neutron is equal to what? 0. Then charge of proton is what? It is positive in nature. Therefore, we are saying that. So this is equal to plus E. Isn't it? It has been experienced by what? So how we are saying this neutral and positive charge by means of various experiments. The scientists have proved that neutron has been neutral in nature and proton is positive in nature and electron is what? Negatively in nature. Right? So from that point we are approving. Then we want to study about a very important conditions called atomic number, neutron number and a mass number. What does atomic number stands for? So atomic number will be represented by a symbol called Z. You have to remember that. Atomic number, the symbol is what? Z. So what is this atomic number is going to tell to us? So it's nothing but it is a number of proton present in a nucleus. So if you take any element, so what is the number of proton present in the nucleus will be represented by a number called atomic number, and it will be represented by a symbol called what? Z. Right? Since the atoms are electrically neutral in nature, we can also say that the number of proton in an atom will be equal to the number of electrons. Therefore, we can say the same atomic number to be what? The number of electrons too. So what we are going to learn about? The atomic number. Atomic number is what? Represented by a symbol called what? Z. So Z is nothing but what? So Z stands for what? So atomic number. It is what? The number of protons present in a nucleus. Or we can say that it is the number of electrons present in a nucleus. So in an atom, the number of proton number and the number of electron number will remain the same. Is it clear to you? Right. Then next about what neutron number. What does the neutron number stands for? The number of neutrons present in a nucleus is called as what? Neutron number. number, and it will be represented by a symbol called N. Right? The next is what? Mass number. So mass means what? It is the mass of an atom. So where the mass arises, it is the mass of a nucleus. We can say that the atomic mass is nothing but what? The nuclear mass. What is the nucleus contain? Nucleus contains protons and neutrons. Therefore, I can say that the mass of the proton and the neutron in the nucleus is said to be what? Mass number. And mass number will be represented by a symbol called what? A. So A is the symbol for representing mass number. So mass number is nothing but it is a total number of neutrons and protons. It is a total number of what? Neutrons and protons. This is the main thing how to remember that. So with this base of the mass number, atomic number, neutron number only, all the things what we are going to study is going to depend upon. So with this only we will differentiate the elements into isotopes, isotones and isobars. And also we will study about the mass difference and binding energy, nuclear fission, fusions, everything will be based on what? The mass number, the radioactivity, everything will be based upon the mass number, atomic number and the neutron number. So you have to be very clearly thorough about that, and the symbol should be remain the same. We should not replace the number symbol, right? So what is the symbol for atomic number? Atomic number symbol is Z, and mass number symbol is A, and neutron number is what? N. Is it clear? What is atomic number? So atomic number is nothing but it's a number of protons in the nucleus. Since this atom is nuclear or electrically neutral, we can say that what? It is equal to number of electrons. So number of protons will be equal to number of electrons. So both we can say that as what? Say either the number of atom, number of electron, or number of proton are called as what? Atomic number. N stands for what? Neutron. So the number of neutrons is said to be what? Neutron number. Then next is what? Mass number. Mass number means what? So the center of nucleus is said to be the mass of an atom. Therefore, the number of proton plus number of neutron is called as what? A mass number. It will represent a symbol called what? A. Therefore, we can write general equation A is equal to Z plus N. What does Z stands for? It is the atomic number, that is number of proton. Number of proton plus number of neutron gives you what? The mass number. Therefore, generally we can write an equation mass number is equal to atomic number plus neutron number. So what is that? Mass number is equal to atomic number plus neutron number. So this is the main equation, so you have to remember that. Now, apart from the name proton, electron and neutron, we are going to learn about a new name called nucleon. What is the nucleon? The summation of one proton and one neutron is called as nucleon. Right? One proton, one neutron. Rendu சேர்ந்ததுக்கு பேர் என்னது? Nucleon. So one proton and one neutron joined together to be called as what? A nucleon. Right? So now we are going to talk about the masses of each particle. So what does MP stands for? So MP stands for mass of a proton. So mass of proton is given by the value of what? 1.672 into 10 power minus 27 kg, which is nothing but 1836 times greater than the mass of an electron. Right? Then mass of a neutron means mass of a neutron is slightly greater than the mass of a proton. So nothing but the value of third or fourth digit will vary. So 1.6749. Right? So 1.67 will remain in the last third and fourth digit will vary into 10 power minus 27 kg. So it is slightly greater than that of a proton. That's all. So mass of a proton is slightly greater than that of mass of the proton is 1836 times greater than the mass of an electron. And we can say that mass of neutron is what? It is 1 is slightly greater than the mass of a proton. Right? So you have to know about mass. For doing a problems, they will give you mass values, and sometimes they will not give you mass value. So we have to substitute the mass value and we have to work it out. Right? Now we go for general knowledge. How to represent this? Right? So X stands for a chemical compound or any elements. Right? So A stands for what? A stands for a mass number. Z stands for atomic number. Always mass number should be at the topmost side. So we can say that the general notation of representing any chemical composition or element is said to be what? X, A to Z. But A stands for mass number. What is mass number? It is number of proton plus number of neutrons. Then Z stands for what? Atomic number. What is atomic number? So atomic number is nothing but what? The number of proton or it is number of electron. X we are going to use. Right? Now we are represent elements. Right. Then next is what? How to represent the charge of a nucleus. So what is the charge of a nucleus? Since the nucleus has only proton and neutron. Neutrons are neutral in nature, that is no charge. Proton is only present, so proton is positive in nature. Therefore, the charge of a nucleus is said to be what? Positive. So which will represent the number of proton? Yes, the atomic number will represent the number of proton. The atomic number symbol is what? Z. Therefore, Z into the charge of proton will give you the total charge of the nucleus. So if they are asking about what is the total charge of the nucleus, we have to represent what? Plus Ze. So if we know about any element, that we know about the number of proton and we know about the charge of one proton. If I multiply, we get the charge, total charge of a nucleus. Is it clear? So we have learned about what? The composition of a nucleus, and we learned about the main important part about the atomic number, mass number and the neutron number, and we have done general equations and we studied about nucleon. What is nucleon? The summation of proton. One proton and one neutron joined together will be called as what? Nucleon. The next we studied about the mass of the different atomic elements, that is mass of a proton, mass of electron and mass of neutrons, and we have learned about the general equation or notation how to represent the element with the help of atomic number and mass number. With the help of this notation only the periodic classification or periodic table has been arranged. The next is what? The charge of a nucleus. So charge of a nucleus stands for what? Plus Ze. Right? Is it clear to you? Now we will go for the thing. Right? What is the thing? So we are going to learn about the atoms are electrically nuclear. Therefore, we can say that the number of protons will be equal to what? The number of electrons. So based on these things, we are going to divide the elements into three types. What is called as isotopes, isobars, and isotones. So what does an isotope stands for? So isotopes means we can say that the element which are having the same atomic number but different mass number. Atomic number means what? We can say A. Different mass number means what? Z. For example, if you see this example, you can easily able to identify. These are the example of hydrogen atom. Hydrogen, deuterium, and tritium. Here, so which is represent the symbol what? X, A to Z. So this is a mass number. See the mass number 1, or we can say that what? So different atomic number. Let's say 1, 2, 3. So it is having what? Different mass number. A stands for what? Mass number. Z stands for what? Atomic number. See, all the number of things is said to be what? 1. So all these elements are having same atomic number but different mass number. We call these types of elements as isotopes. Right? Is it clear to you? So it is called as, first one is called as hydrogen, second one is called deuterium, and third one is called tritium. So these are the same elements of hydrogen families which is having different mass number but having the same mass number. We call these types of elements as what? Isotopes. So these isotopes will be depends upon the abundance. Naturally depends upon what varies due to the abundance nature. So each one will have a different abundance, right? So one will have, if we take carbon, we can say one carbon will have more percentage present in the nature, and some will be very least and some will be more least, right? So each isotopes varies depending upon the abundance which has been present in it, and also we can say that so isotopes is not a natural one, right? So it has been produced. Isotopes can be produced artificially through laboratories and also due to the things called cosmic ray emissions, right? So isotopes are not natural. Most of the isotopes are not naturally present. They have been produced by in laboratory process by means of any bombardment of the particle, or it has been produced into the cosmic rays, right? These isotopes have been used in many fields in the biotechnology in order to improve our cultivations, and also it treats for many diseases also. So isotope plays a very important role in our life. So isotopes is not naturally occurring, right? So we are creating the isotopes based on our needs, right? So isotopes are natural element which has been what? Created in lab or through cosmic rays. So the chemical properties of these isotopes is only depends upon what? The electrons present in it. Therefore we can say that the same electronic configuration will be followed for all the isotopic components. Therefore we can say that all the things will be placed in a thing called what? Isotopes. Isotopes plays a very, very important role in our day-to-day life. Right? Now, we go for isobars. So, what is isobars stands for? Reverse of isotopes. What is that? It has the same mass number but different atomic number. Same mass number means what? See, the upper portion will remain the same for all these elements and the bottom portion has been revealed. We call that as what? We can call that as what? Isobars. We can call that as what? Isobars. So, isobars means we can say that mass number will remain the same and the atomic number will vary. You can call that type of elements as what? Isobars. If you see this example, you can see that sulfur, chlorine, potassium, calcium, everything is having a mass number equal to what? 40. But what is the atomic number? It is varies from 16, 17, 18, 20. Everything is varying. Therefore, we can call this as what? Mass number. Right? This is called as what? We can call this as isobars. So it's a reverse of isotopes. So isotopes and isomers. The last one is said to be isotone. Not it is here isotopes. Here it is said to be what? Isotopes. So what is isotone stands for? Different element which will have the same number of neutrons. Then it is called as what? Isotones. Right? So different element having what? Same number of neutrons. So here you can see, if I take boron and carbon, if I subtract 12 minus 5, 13 minus 6, what do I get? 7, right? So the 7 is what? Same here also, there also, right? So the difference between the mass number, if you want to calculate the number of neutrons, what you have to do? You have to subtract mass number with the atomic number. So from here we can say that the total number of neutrons present will be what? Mass number minus atomic number. So mass number is 12 minus atomic number will be raised to what? 7. Here mass number 13, 6 minus will be raised to 7. If the element, the difference is said to be equal, then that type of elements are said to be what? Isotones, because it has what? Same number of neutrons. Is it clear to you? Can everybody get it? So we have seen about the basic fundamental about the nuclear physics. We have learned about the mass number, atomic number and the neutron number, and with the help of that how the elements has been classified into isotopes, isobars and isotones. Right? Is it clear to you? So in your examination they will give you different elements and they will ask you to group them as what? Isotopes, isobars and isotones. So you have to see that. So if it is a tone means what? What it will be at bottom one. This is called as what? Atomic number. So atomic number remains the same means it is said to be isotopes. Mass number remains the same means it is said to be what? Isobars. Then we can say that what isotone means the number of neutrons remain the same means it is called as what? Isotones. Is it clear to you? Right. Now in the next thing we will go for what? The atomic and the nuclear mass and we will study about the mass difference and the binding energy. Right? We will go for it. So now we are going to study about the atomic and nuclear mass. So what is the atomic mass and nuclear mass stands for? So if we want to say that we already learned that, what we learned? So we learned that the size of the mass of the nucleus is nothing but it is considered as what? A mass of an atom. Because all the protons and neutrons will be present inside the nucleus at the center. Therefore, we are saying that the mass of the nucleus will be equal to what? The mass of an atom. If we want to measure the value of the atom, means we can say that the mass of the nucleus is nothing but the value of 10 power 25 kg or less than that. So that value is very, very small value. So in order to represent that small value, we will practically use another unit in order to have a convenient manner. We use a special unit called as atomic mass unit. We call that unit as what? Atomic mass unit. So the mass of a nucleus will be represented in terms of what? The atomic mass unit. It is one of a practical unit in order to measure the mass of an atom or a mass of a nucleus. So what that atomic mass unit stands for? The atomic mass unit is nothing but it is defined as a mass of 1/12 of a mass of a isotope of a carbon atom. Right? So what is one atomic mass unit is? The atomic mass unit will be represented by a symbol called U, and this one atomic mass unit is defined as a 1/12 of the mass of the isotope of a carbon and C612 atom. Right? So we are taking 1 by 12 value. What is 1 by 12 value? 1 and one power. So we are taking that value of a carbon atom. Why we are taking carbon atom? Because the carbon atom has been naturally occurring in an abundant manner. Therefore, we are taking the use of what? Mass of a carbon atom. So how to evaluate the equations? So 1 U stands for that is equal to mass of a carbon atom divided by the total mass number. So what is the mass number? It is 12. So what is that? Divided C612. Right? C612 here is stand for mass number and this stands for what? Atomic number. So we are taking the mass of the carbon atom divided by the 12. So what is the mass of the carbon atom? So it will be measured using an instrument, right? 1.99 into 10 power minus 26 divided by 12. And use the value equal to what? 1.66 into 10 power minus 27 kg. So that is a practical unit in which the mass of an atom or a mass of a nucleus will be measured. Right? Since the mass of a real nucleus is in terms of kilogram, if we take the values very less, therefore we are saying that in terms of what? Atomic mass unit. So atomic mass unit is a special unit in order to represent it. It is nothing but we can say that it is 1 by 12 of a mass of a isotope of a carbon atom. Its value, value is equal to what? 1.66 into 10 power minus 27 kg. They will ask you in 1. So what is the value of 1 atomic mass unit? You also learn the same thing in your chemistry also. So 1 atomic mass unit is equal to what? 1.66 into 10 power minus 27 kg. When we convert that into electron volt, we will give the value equal to 931 million electron volt. So you can say that 1 atomic mass unit can also be said in terms of what? 931 million electron volt. In terms of electron volt, if I want to represent, we can say that is equal to what? 931 million electron volt, right? Right. So in terms of similar to this, we already learned about what the mass of a proton, mass of neutron in terms of kilogram. We said that 1.66 into 10 power minus 27 kg. So that is kilogram minus 10 power minus 27. If I put on boiling solid liquids, it will give rise to what? Very less value. So therefore, we conveniently represent that type of mass in terms of what? Atomic mass unit. If for the term we can say U. Right? If the number has been represented in terms of units, the U stands for what? Atomic mass unit. So we can say that mass of the neutron is nothing but 1.00866 times of atomic mass unit, and mass of proton is this, and mass of hydrogen atom. What is the mass of hydrogen atom? Hydrogen will have one proton and what is that? We have the equation, we write the equation like 1 point. So what does represent? It is a mass number. It is what? Atomic number. Right? So atomic number stands for what? Number of proton or number of electron. So it has 0 neutron. There is no neutron will be present. It's subtracted. 1 minus 1. The value is 0. So in a hydrogen atom we have 1 proton and 1 electron. There is no neutron will be present. This mass of a hydrogen atom will be represented as. Right? Similarly, mass of a carbon 12 atom is nothing but 12 times of atomic value. So if you multiply the value by 12, right? So 1.66 into 12, it will give this value equal to what? 1.99 into 26 into 10 power 26 kg. So simply we can multiply, right? Therefore, so this is multiplied 12 times the atomic mass unit value is what? 1.50 into the value into 11. So these are the terms in which what? Atomic mass unit has been represented. Right? Is it clear? What is atomic mass unit? Is it clear? So atomic mass unit is nothing but is a convenient unit which has been represent the mass of an atom or a nucleus. Right? Both of the result is the same. So that's why we are not separating atomic mass and nuclear mass. We are not separating. Commonly we are calling as what? Atomic and nuclear mass. Right? Then next is what? We are saying about size and density of a nucleus. What is the size? As already said by us, what is the main size? We learned that the atom size is 10 power minus 10 meter, and the nucleus size is what? 10 power minus 15 meter. So we are going to study deep into it. Different kinds of experiment verify that the size of a nucleus is what? Spherical in shape. So you know that we already studied about the gold standard experiment, isn't it? So they say that a small spherical shaped ball-like structure has been placed at the center. We call that as what? Nucleus, and it has positive charge, and it carries what? Positive charge. Therefore, experimentally it is proved that the size of the nucleus is what? spherical in shape, and they are saying that what is Z stands for? Z is what? Atomic number. When atomic number is greater than 10, then they are representing an empirical equation to represent the size of a nucleus. What is an equation? This is a very famous equation. The radius will be equal to what? R0 into A power 1 by 3. What does A stands for? A is nothing but what? Mass number. So therefore A is a mass number and R0 takes a value of 1.2 Fermi. F stands for what? Capital F stands for Fermi. Capital F stands for what? A Fermi. It is one type of measurement in terms of meter, right? So R0 is equal to what? 1.2 Fermi. 1 Fermi is equal to, we can say that it is 10 power minus 15 meter. 1 Fermi is equal to what? 10 power minus 15 meters. So how we are representing answer? Answer is 10 power minus 10 meter. Millimeter, 10 power minus 3 meter, like that. 1 Fermi takes the value of what? 10 power minus 15 meter. Right? It is a very important equation to calculate the radius of a nucleus. So if the mass number with atomic number is greater than 10, then that type of elements can be following this rule. The radius R can be going to be equal to what? R0 into A power 1 by 3. A stands for what? Mass number. So this equation has been most probably answered in a simple 2 marks problems or 1 mark problem. They will give you an element and they will ask you to calculate what? They will ask you to calculate the radius of it. So with the help of that, you have to find the mass number and you have to take the cube root for that and you have to know the value of R0. What does R0 value stands for? It is 1.2 Fermi. Some of the old books it has been given to me what? 1.3 Fermi. Old books are now they have been given the value 1.3. But now newly edited books have been giving the value of what? 1.2 Fermi. Fermi takes the value of 10 power minus 15 meter. Right? Is it clear? So you have learned about the atomic and nuclear mass, and we have learned about what? The size and density of a nucleus. In order to calculate the size, we have followed. Now we go for the nuclear density. What is nuclear density? The formula we know. Density means what? Mass by volume. So here also density is equal to mass of a nucleus divided by volume of a nuclei. So how to calculate the mass of a nuclei? So nuclei has what? Proton and neutrons. Right? So we can say it's a mass number. So mass number gives you what? The total number of protons and neutrons present in a nucleus. So into mass of a nucleon. So you can say that it is A dot M. So mass of a nucleus will be represented by what? Mass number into mass of a nucleon divided by. What is the volume formula? For it is spherical in shape. That what is the volume formula? 4 by 3 pi r cube. So 4 by 3 pi r cube. Is it clear to you? Right? What is that? R stands for what? R value takes the value of what? R not A power 1 by 3. So we are substituting for it 4 by 3 pi r cube. Instead of R, we are substituting this value. So we are substituting the value R not cube only. So A power cube will cancel and will reduce to be what? A. Is it clear to you? I have directly substituted it. So if you want, we can say that. So we know that 4 by 3 pi r cube will be there. Instead of this r, we are going to substitute this value. You can substitute the value 4 by 3 pi r naught cube a power 3 by 3. We can cancel. Therefore, this becomes equal to what? 4 by 3 r naught cube into a. Then what will happen? This mass number and this mass number will cancel. Then it becomes m divided by 4 by 3 r naught cube. We know all the values, right? So mass of that value, everything we know. So from this it is clearly known that this equation, the density is equal to what? Mass by 4 by 3 pi r cube. It clearly proves that the nuclear density is independent of a mass number. So there is no A loss. A gets cancelled. Therefore we can say that nuclear density is independent of a mass number, or otherwise we can say that the element which is atomic number greater than 10 will have a same density. So which determines the important characteristics of an element, right? So it's a very important characteristic to know that when all the elements is having an atomic number greater than 10 will have all same density value will be there. So the density of the thing will remain same for all the elements. And that is an important characteristic because the nuclear density is independent of a mass number. Is it clear to you? So you can say that atomic number which is not having greater than 10. Atomic number which is greater than 10 will have what? The the same density. Will have the same density. Therefore, if we substitute the value, we know the mass value 4 by 3. For all that, we know the value we have found to be equal to what? 1.2 Fermi. What is Fermi? Takes the value of 10 to the power minus 15. If we substitute the density has been found to be equal to what? 2.3 into 10 to the power 17 kilogram per meter cube. So that is a standard value for most of the elements which has been present in your periodic table. Is it clear? Right. So now we have studied about what? We have studied about the atomic and nuclear mass, and we have studied a new concept called atomic mass unit. It is one of the specialty or an important way or simplest way to represent the mass of the nucleus or mass of the atom. Right. And we have studied about the size and density of the nucleus in our atom. Here, if I like say that mass of the nucleus is most probably it is measured by instrument called Bainbridge mass spectrometer. So Bainbridge mass spectrometer is one of the instruments helping to measure the mass. If I are saying that we ignore the isotopes, we already learned what is isotope. The same element will have what? It will have same atomic number and different mass, right? So everything will be occupying single space. It will not be placed at a different position in the periodic table. So if I measure the any element value by ignoring the isotopes or by the isotopes, I get only what? The average value by to this abundance of substance which has been present. Right? So if we take any measurement of mass, we have to consider the isotopic mass of that. The isotopic mass, if I am taking it, means it will give me an average mass of all the abundance of substance value to that what? Abundance of that element present. Right? And also, we will say that if I want to take, we are not measuring the mass of a nucleus. Right? Usually, we will conveniently say that what? The mass of a nucleus is nothing but the mass of an atom. If I take an atom, it has what? Mass of electrons too. So in order to find the mass of a nucleus, the mass of electrons should be subtracted from that. So that is the thing. So sometimes it will be concluded in it, and sometimes we will neglect that. Right? So mass of a nucleus, if you want to calculate separately, means you have to separate, you have to minus. So we have to remove the mass of electron present in it. Because we are only will take the atoms, right? So we will take the element and we'll place it in the mass spectrometer, it will show the total mass. So the total mass includes what? Including electrons. Right? So if you want to calculate the mass of a nucleus, you have to separate the mass of electrons from it. So that is the thing we have to do. Sometimes it will be taken into account, sometimes they will neglect that because that is not going to affect the most result, right? So that's what it has been. Right? Now we are going for a very important concept called what is meant by mass difference and what is a binding energy. So that is your first question. We are going to learn for your 5 marks too also. Right? So for binding energy of various elements, how to graph it over. So that is the first question and a very important question which has been frequently asked in your board examinations. Now we go for it. So important concept is what? Mass effect, binding energy and the curve